Hello viewers, welcome to my channel Learn with me. After a very long time, I'm doing the video of 8th standard maths because of some work. Okay, today let us discuss about the properties of rational numbers. That the first one is closure property. Whole numbers. First, we are going to see the closure property for the whole numbers. You know already which are the whole numbers. The whole number set is started with 0, 1, 2, 3 and so on. Okay, here we can see so many properties related to the whole numbers on the mathematical operations addition, subtraction, multiplication and division. So now what is our aim is we should see the closure property is satisfied for addition, subtraction, multiplication and also division. Here they given so many examples. So first example, 0 plus 5 equal to 5. We know that if we add any whole number with another whole number, the result is again a whole number. For example, one more, 4 plus 7. The answer is 11. 11 is also a whole number. So that what is the answer? What is the conclusion? Whole numbers are closed under addition. What is closure property tells us? If we add any two whole numbers, the result is again a whole number. Next, we can see the closure property is satisfied for subtraction or not. Here, we took examples 5 minus 7 is equal to minus 2. If we subtract 5 and 7, the answer is minus 2. But minus 2 is not a whole number because whole numbers are always a positive numbers. That's why minus 2 is not a whole number. That's why what is the conclusion? The closure law not satisfied for the subtraction. One more example. Suppose 3 minus 5. The answer is how much? Minus 2. It is also not a whole number. That's why. But if we subtract 5 minus 3, it will 2. But in the opposite way, it is not possible. That's why totally subtraction is not satisfied for a closure property. Next, we can see multiplication. If we multiply any two whole numbers, the result is again a whole number or not. Yes, whole numbers are closed under multiplication because if you multiply any two whole numbers, the result is again a whole number. That's why it is satisfied. Next, division. Its meaning is if you divide any whole number by another whole number, the result is not closed under division because sometimes if we divide 2 by 3, the result is not again a whole number. That's why division is not satisfied for the closure property. So what is the total conclusion is closure property satisfied for addition and multiplication, not for subtraction and division. Next, we should check it for integers. Let us now recall the operations under which integers are closed. First, for addition, we are going to check. Integers means we already know that in the previous classes, positive numbers, negative numbers along with 0. Is it? So that's why here the example is minus 6 plus 5. The answer is minus 1. It is an integer. Again, minus 7 plus 5. Minus 7 plus of minus 5 is an integer. Yes, let's see. Minus 7. Then plus into minus becomes minus. Then 5. If we add these two integers, the result is minus 12. Yes, it is an integer. Next, that's why in general what we should see here, a plus b is an integer for any two integers a and b. Closure property satisfied for addition on integers. So the result is integers are closed under addition. Next, for subtraction. Here the example 7 minus 5 equal to 2. 2 is again an integer. Then 5 minus 7 5 minus 7 is an integer. Yes, absolutely right. Because 5 minus 7, the result is becomes minus 2. That's why, what is our conclusion? Integers are closed under subtraction also. Next, here so many examples are given. Now let us see for multiplication. 5 into 8 is equal to 40. 5 is how much? 40. 40 is an integer or not? Yes, absolutely correct. Next, minus 5 into 8, minus 40. It is an also integer. That's why, what is the conclusion? Integers are closed under multiplication also, but integers are not closed under division. Why? Because we should see here this example. If we divide 5 by 8, the result is not an integer. It should be a decimal or a fraction. That's why division is not closed under integers are not closed under division. Okay, next we should see the rational numbers now. What is the definition of a rational number? Just recall this one. A number which can be written in the form of p by q, where p and q are integers and q is not equal to 0, is called a rational number. Suppose here example 1 by 3. It is in the form of p divided by q. Here this in general p and q are what? Integers. It should be integers, but denominator should not be is equal to 0. This is the definition of rational numbers. One more example, 2 divided by 0. It is not a rational number because in the denominator 0 is there. That's why rational number means in simply what? It is in the form of p by q and q is not equal to 0. This simply definition is. Okay. Here so many examples they are given. Minus 2 by 3, 6 by 7, 9 by minus 5 are all rational numbers. Again here they given some properties. Again what? A closure law, again closure property, associative property, they are satisfied for the rational numbers. Then multiplication properties, the division is there. Okay, these all properties we can discuss in the next class. Thank you, friends. If you like the classes, please like the videos and subscribe to my channel. Learn with me. Thank you.